All right. Yes. What about it? What about it? If you're not enrolled in the course yet, if you are a waitlister or a crasher, and you're not enrolled, you would need an ad code. Yeah. And nowadays it's ad authorization. You don't even need to get a code. So, sorry? Oh, you're in Overland, yeah. So if you already signed up for courses in the spring, intercession is a part of spring semester. So if it's not that far over, you should be able to get a permission to do that easily. You have to go to admissions though. So after class, you go there. All right. Anything else? All right. So the way I try to do this is to kind of step through the way we would try to answer a question that we can answer statistically. So we're going to go through the definitions. I'm never going to ask you on a test or a quiz just to define statistic. I'm never going to ask you to do that. I'm going to ask you to use the words correctly. That's it. That's what I'm going to do. So, can somebody give me something about like gross response students that you would be interested in? For example, the percentage of gross response students who smoke or something. Or maybe something more interesting. I don't know. Anybody curious? Or the average age of gross response students or something. Anybody curious at all about all the other people?
The percent who graduate?
Percent who graduate. Kick ass. All right. So in terms of graduation for gross response, that's earn an associate's degree, maybe?
Sure.
Okay, I like it. So the percentage, so let's say we're interested in the percentage of gross response students. This is as good as it gets, by the way. That's going to be interesting. The percentage of gross response students who earn an associate's degree. Get in there. And associates, let's say in 3 years. Technically, it's supposed to be 2 years, but we all know life don't let that happen most of the time. Some of us are living that experience. Right? All right. So, what's the group of people we're trying to say something about? What is it, obviously? What's the group of people or things that we're trying to describe somehow?
Gross response students.
All of gross response students, right? Okay. So the population is the entire group or a collection of things or people that you wish to describe. All right. I'm only going to lose a few people just based on my handwriting. I understand. It happens. That's for me to grade. Now, if it's just us, if it was just somebody, one of you guys in this class that was curious about this, are you able to talk to, or able or want to talk to every gross response student that has left or that has been here for 3 years? Do you want to do that? Do you want to do that? Some of you guys do, it sounds like. You guys can do that. What are we in statistics? What do we normally do then if it's either impossible, not feasible, or not desirable to analyze the entire population? What do? Take a sample. We all know this, right? Most of us know. So a sample is simply a subgroup of the population. Okay. that's exciting. So you guys are a sample. Would you guys be a good sample for this study?
Yes.
No,
Why not?
it wouldn't be a representative of the entire population.
Yes, exactly. All right, right? You guys, I'm not saying you're bad people, but this would be a bad sample. Because if you're trying to say something about all Grossmont students, and you certainly are Grossmont students, and if you're not, you're freaking me out a little bit, but you are. But why is this a bad sample? It's not representative. Why can you say that it's not representative? Why would it be a good, not an assumption, but why does it seem apparent that we didn't try to even make it representative of the population? What's wrong with us, this sample?
Because this is a small percentage of what is the total amount of the people.
That almost doesn't matter. This is not the most ideal sample size, but this is not a bad sample size.
On a list of graduated?
Okay, so the thing about this study is this is going to be what's called a longitudinal study. So like you guys could be my sample, and then I follow you for 3 years. Do you see what I'm saying? Is that cool? I mean, that's pretty much how this is going to have to work. You with me? So
I was getting confused.
I'm with you. So the way this would work is I would take a sample and then follow them as they go through. And then 3 years later, I can see what percentage of them. Does that make sense? Because otherwise, it's a little bit weird. I agree. It wasn't. I could have, but I like the idea of it. But that's how it would work. So you guys could all be in the sample. Okay. So what else is it? Somebody else had a.
It's not random.
Not random. Okay, I like it. But what does random mean?
It like picks people from everywhere.
Okay, that kind of goes along with trying to be representative, right? Okay, I like it. So that's one way.
We're all in a statistics class, so maybe we like math.
Okay, good. You are all in a 4-week statistics class that starts at 9 a.m. Is it, now this is getting to the answer, but is it possible for every Grossmont student to be in the sample if you guys are my sample?
No.
No, because does everybody need to take statistics? Is everybody able to take stats during the 4-week intersession? Is everybody able to take a course at 9 a.m.? Holy shit. So if I'm trying to say something about a population and my sample is comprised in such a way that not everybody had a chance to get in it, that is not random. We have to assume it's a bad sample. You guys could actually be spot on. You could be a perfect representation of Grossmont, but I just don't know. I have to say that you more than likely aren't. You would be what's called a convenience sample. Isn't this convenient? I'm going to do a study. You guys are here. I'm going to use you, right? But convenience is I didn't even try to make sure that it was representative of the population, right? So a little sub thing here is random sample is the ultimate goal. And a random sample ensures that every element, every item or person in the population has an equal chance to get into the sample. Every thing or person in the pop has an equal chance to be in the sample. Doesn't that sound like the goal we want? Doesn't that sound like it would be the best possible representation of the entire population? Now I could take a perfect random sample and it still just doesn't represent the whole population, but that's just random. That's just probability. If I was trying to figure out the average age of Grossmont students, would it be impossible for me to randomly select, blindfolded, and take 80 people who are younger than 20? Would that be impossible? Let me try again. Would it be impossible for me to randomly pick 80 Grossmont students and they're all under 20? Would that be impossible? No. Would it be likely? No. But would it be impossible? No. So what we do is we try to maximize the probability that our sample is a mixture of all different kinds of people on campus. And the best way to do that is to make sure that everybody had a chance to get into the sample. Does that mean that every random sample is perfect? Oh, hell no. Right? I like it. Anybody paying attention at all to, I don't know, the election coming up, the Are you guys actively avoiding it maybe? I don't blame you. What a weird time to be like around 18 or something. Anybody gonna vote for the first time soon? A few of you guys? I'm sorry. I'm not gonna bring too much politics. I don't care how you feel about whatever. Everybody can agree this is a shit show, either way you look at it, right? But that's not my point. Sorry, Dean. No politics. So if you've paid any attention to polls, have you ever seen something like Sanders, blah, 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 Biden, blah, blah, and at the very bottom it's plus or minus 4% or something, right? Okay, that is something we'll be able to calculate. They don't say, I don't know, give or take 4, sure. No, it's a math equation that we are going to learn later this semester to see where the shit that thing came from. Why is it 4 there and 3 there? Well, maybe they took a larger sample here, so they have a smaller error, right? So we'll see that later this semester. But that's just the idea that samples are random. Some of them are going to represent things better than others, but that's just part of life. And that's one thing I love about statistics is it's the most honest math, right? It's 7, give or take 3, right? I think it's this. Who knows? But that's life. Everybody wants statistics to tell them what the next lottery numbers are going to be. Nope, right? Ain't gonna happen. What about Dow Jones? Dow Jones looking good. Let's make a prediction. Oh shit, we're dead, right? So none of that's gonna work. But sorry, I keep going off on tangents. My little brother, for example, he's now this. He always had to say, Jeff, are you still teaching probability? And I'm like, yeah. And he's like, well, that's a sham, man. I'm like, okay. It's like everything's gonna happen or it ain't. It's all 50-50. I'm like, dude, I'm so happy you didn't become a doctor or something. Doc, what's my chances? 50-50. No, not good. So I think we can all agree that probability never tells you definitely. But without it, there's so many decisions we could never really make well. Okay, maybe. Anybody play poker at all? Poker. Pot odds, yeah?
I just came from Vegas yesterday.
Oh, there you go. How'd it go, if I can ask? Anyone else? Okay.
200.
Well, if you're a real poker player, you can survive some crap because you're playing the long game. You're trying to play the probability so that eventually you'll get some money. Mm-hmm. So poker's beautiful, all about. So people tell me, why don't you play poker, Jeff? It's because I don't have a poker face. No, you could tell immediately what's in. So I'd have to wear big ass glasses, cover my whole face. I don't even know if that's allowed. Okay. Coming back. So we have a group of people or things that we want to describe. We can't talk to all of us, too many. So we take a sample and we try to make it random. That's our ultimate goal. What would we do once we got that sample? So we're trying to talk about the percentage of gross students. So once I can take a sample, let's see. I would wait 3 years and then what would I look to see if what happened? What would I do? Yeah. So I'd have a question. Did this person in my sample get an associate's degree or not? Did this person get an associate's degree or not? So forth. With me? So that is something called, this is not surprising, hopefully, that's called the variable. The variable is the question that I'm asking. So if I was taking a sample of people, trying to figure out the average age of gross 1 students, my question would be, how old are you? So the variable would be age. Right? So variable is related to the question you're asking. So in this case, it would be, are you getting an associate's degree after 3 years? Right? So I have to wait 3 years and then see if you're getting an associate's degree. And you guys, I don't know, I said it really quickly earlier, that's something called a longitudinal study, where you pick a group and then you follow them for however long. In this case, 3 years. All right, everybody with me? A little bit. Once you ask the question, what do you expect back? Answers. So the answers to that question is called the data. That's not surprising, right? Data is a collection of all the answers to the question. So in this case, my data would look like yes, no, yes, no, yes, no. Whatever emphasis is still yes or no. Okay. Maybe. You guys with me? See the flow of this shit? I want to say something about these guys. Here's the people I can work with. Here's the question I'm going to ask them. Here's all the answers I got. All right. Once you get all the answers, what would you do then? In this case, what would we do? All my answers are, what do my answers look like? My data is a list of yeses and nos. And what am I trying to figure out?
The percentage.
The percentage who had got an associate's, right? What did I say here? Yeah. Hello. So how would I calculate that?
Count the yeses and divide by the total.
Yes. Right? So the next thing I do after I get my data is to analyze it, and the number I get is called a statistic. Now, leave 5 blank for a second. The statistic is the actual analysis I do with the data. Get a percentage, get an average, whatever. Right? So I get a bunch of answers. I'm going to do something with it, and that's the statistic that I get. Analysis of data from a sample. So a quick way to say this is it describes a sample, normally numerically. That's what that word is, believe it or not. That's neat. It actually looks partially like it's in Arabic. Okay. I know a little bit of Arabic, not much, but not that much. Describes a sample numerically. Now watch. This doesn't mean anything to us yet. Statistic, sample. There's got to be a corollary to this for a population. So if I was describing an entire population, that would be called a parameter. Population. Sorry, you're in the splash zone. Population parameter. So parameter just is this, but for a population. Does that make sense? Is that right? You gotta love that shit. So if I said 12% of all Grossmont students smoke. Let me say it again. 12% of all Grossmont students smoke. Is that a parameter or a statistic? Why is it a parameter? I said all. So that means it's talking about a population. The next answer is going to be statistic. You know that, obviously. But what if I said the average grade for the 88 selected students was 70? Why is that a statistic? Because it's describing sample. The 88 selected. You with me? It's that simple. Now, both of these are either a percentage or an average. It's some kind of analysis I did. So some reason I say what I say and people think that this is the same as this. No, this is a number that describes a population. This is that same kind of number that describes the sample instead. How we doing? So in general, in statistics, in a lot of statistics, we're trying to estimate a parameter using a statistic. Let me say that again. Because we're trying to say something about this, but we're using this. So we're trying to give an idea of what this is using what we find here. No, yes, maybe, no, maybe, no, no. Shit. Okay, all right. Woo, that's a lot. Did you soak that in for a minute? We're going to change gears in a second. Any questions about all the stuff over here? This is the most basic terminology of statistics, and some of this you already knew, right? Some of this is words you know that now have a slightly different meaning, but still, this is really cool. This is called a variable because a question has how many possible values? Well, it depends. It has a lot. How old are you? Well, that's got possible values between 0 and 100 and whatever the oldest person, right? How tall are you? So I love that that's the variable. And that's exactly what algebra says. That's the variable. It's the thing I don't know yet until I ask. Then I get the answers, data. Maybe. Okay, I'm going to erase all this. Hopefully, I don't know if I got it all. Let's see if this got it all. For those of you playing along at home, no. Why did you shift? Okay, I think that got it all. Okay. All right, all this is going away. Whoa. So let's talk about a couple things here. Let's talk about types of variables, types of data, really. We'll first break them down into two main types, and then we'll further break that down into four. So it feels a little bit like biology, but I don't know. Kingdoms and phylums and strata, who knows? That's about all I remember about biology. So there's something called qualitative, and there's something called quantitative. Can you guys read that in the back? Can anybody read that? First time, yes. Can you guys see that in the back? I had a teacher that would do this, and then you take the X equals 7. It was terrible. We all sat in the front row. There was only 4 of us in the class, so we all sat in the front row. All right. What's the root word? Let's start with this dude. What's the root word of quantitative? Quantity. So what's that one most likely referring to?
How many numbers?
Yeah, numerical parts. Something can be measured. So numerical, truly numerical. What the hell do I mean by truly numerical? Is your zip code a number? Yes. Is it truly numerical? No. Because if you subtract 2 zip codes, does your answer mean shit?
No.
So if you try to do something numerically to it, the answer doesn't mean anything. This is not what I'd call truly numerical, like your social security number or number on your jersey. That's just another name for you, like your social security number. So quantitative, root word, quantity. So most of the measurements are going to be in there, but they are truly numerical. Holy crap in half. Let's get there's those letters. Truly numerical data. Whereas qualitative, the root word is quality. It's also called categorical data. So things that aren't really number, like hair colors, types of cars, stuff I just said a minute ago, zip codes, social security numbers, things that identify somebody, don't measure somebody or something. Right. So this is categorical data. Names, gather. All right. So those two breakdowns, those two are pretty simple. Numbers, not really numbers. Here come the ones that aren't so straightforward. We're going to break it down 4 more ways. Levels of measurement. And the word measurement is going to seem a little weird at first, but the first level is basically has no measurement to it. So I like that. The first level is called nominal. Somebody like Stephen King? Have you ever read any Stephen King books or seen any? Yes? One other person? 2 people? 3 people? All right. If you like Stephen King, you should also like Richard Bachman. Do you know Richard Bachman? Same guy. Richard Bachman was Stephen King's pen name, also known as plume de nom in French. Nominal are names, purely names. So somebody's name is obviously nominal. Your hair color is nominal. Your type of car you drove in is nominal. Right? The type of shoe you're wearing, nominal. Nominal. I'm not saying it's basic. I'm just saying it's nominal. That's the level of measurement. 0 measurement, just the name. So if I put shoes, if I started listing what brand of shoes are you wearing? I like it. Is that Converse? No, what is that?
Vans.
Vans? All right. What brand of shoes are you wearing?
Adidas.
Adidas. If I just kept going, right? I'm wearing some funky ass, what is it, Solomon? Whatever, hiking shoes. If I just keep listing that, does anybody have any trouble with that I'm just listing those? Not really, you're like, oh, that's boring, but who's upset because they're not in the right order? Nobody, hopefully, right? But dude, it's better than that. No, I'm not going to get into that. So, nominal, there's nothing except just pure names. There's not even an order they want to be in. The next level is called ordinal. That kind of gives it away, hopefully. Ordinal data is names that must be in a certain order to make sense. What the hell would that be? Have you ever been in a restaurant? You saw those little cards they ask you to fill out? Rate your experience here. Right? It could be ratings, rankings. It must have an order. There's an inherent order. Inherent. What does inherent mean? Inherent. Not inherit, but inherent. Anybody know what that means? You're like, I thought this was math class, dude. I know. Nobody knows? So inherent, if you have an inherent quality, that means it's something in you, it's something that's is a part of what you are. It's inherent, an inherent quality. So I can put names of anything in whatever order, alphabetical order, order of the number of letters in the word that describes them, order in what I like and what I don't like. I could put them. Is there any order they want to naturally be in? No. But what about rating a restaurant? It wants to be in the order poor, fair, good, excellent, right? So if you got a little card and those are out of order, you would go, wait a minute, what are you people doing? Or have you guys ever rated a faculty member? You know, we have to fill in the bubbles, right? I like it. And so what if on the top you notice they had rearranged, it started agree, strongly disagree, strongly agree, neutral. Wouldn't you go, wait a minute, what the shit are you doing? Yes, no? You wouldn't care? Just Christmas tree like you always do? No. Come on. Yes, you guys see what I'm saying?
Yeah.
So there are certain things that aren't just names. They also have this order they want to be in to make sense. That's ordinal. The freaking name tells you what it is. These two are mainly qualitative. That should make sense. Especially when I tell you what the next two are. Anybody remember what interval meant in like algebra or just in general language? Interval. What does that mean? Can somebody use it in this sentence? Or tell me what it is.
Like one number to another number?
Yes. So an interval, you can have an interval of time, like the 50s. The interval of the time of the 50s or whatever, right? And now we're back in the 20s. Okay. So, interval is got a beginning and an end. So can you tell me how, like the 50s, how long was that?
10 years.
No way. 10 years. You guys with me? So if I had an interval of temperatures, on this island, it could be anywhere from 20 degrees to 80 degrees. Well, how long is that interval? 20 to 80. 60. Okay. So what operation are you using? Subtraction. So interval is data where subtraction makes sense. Not just can you subtract. Can you subtract 2 zip codes? Yes. You can, totally. Of course you can, right? What's your zip code?
92105.
92105. Mine is 91941, I think. So if you subtract those, you get a number, right?
Mm-hmm.
Does it mean anything? Nope. So it doesn't make it interval just because you can subtract it. It has to mean something. What year were you born? Sorry, I'm picking on you.
2001.
2001. Oh my God. So you didn't even know about the Y2K thing. You totally, I'm sorry. You're like, dude, ancient history. Sorry. I'll stop. So if I was born, anybody have a guess when I was born? I was born in 1972. So if you subtract those 2 years, do you get something that makes sense?
Yeah.
Yes, you get what?
The gap.
Yes, how different in ages we are. You with me? All right, so years born. The year you were born, that is interval data. Because if I took 2 of them and subtracted, I get something that makes sense. Come here. Maybe we can use a different color. Subtraction makes sense. So the whole thing about makes sense is huge. Not just can you subtract them. Does the answer make sense? Do years have an order they want to be in? Mm-hmm. So this builds. Every interval thing is also ordinal, it just adds in subtraction making sense. Every ordinal thing is also nominal, it just adds in an order it wants to be in. You see what I'm saying? So when I ask you to identify what level something is, you tell me the highest level it gets. Nominal is the lowest, ratio is the highest. And what's ratio going to be? What's ratio mean in math? What operation does ratio imply? How do you make a ratio? Divide, right? Ratio is like a fraction. It means division. Are you with me? Yes, yes, yes?
Mm-hmm.
So this is where division makes sense. Because of that, that also has a second thing to it. 0 has to mean what it's supposed to mean. What the hell does that mean? I don't know. So for example, how many temperature scales do you guys know? It's okay if you just know 2. What are the 2 main ones? Celsius and Fahrenheit, right? Celsius is what every other country on the face of the earth uses. And then you got us, because we're special. So you got, there's a third one though. Anybody know the third one? I'm sure somebody does. Kelvin. Kelvin is the one. So in Fahrenheit and Celsius, is 0 the coldest you can get? Does 0 mean the absence of what it's measuring, the heat? No, believe it or not. I know we're in San Diego, so you're like, well, no, actually 20 is the coldest you can. No. Can you get colder than 0?
Mm-hmm.
Of course you can, right? I like it. So 0 doesn't mean what it's supposed to in the 2 scales we use. Because we made the scales make more sense to our everyday life. Okay. So what's twice as hot as 0 degrees? There is something that is twice as hot. But what is 2 times 0?
0.
Freaking 0. So division wouldn't make sense if 0 didn't mean what it's supposed to mean. I don't know if you guys get that, but this is a way to figure out. Is something ratio? Well, do 2 things divided mean something? Like if somebody is 40 years old and somebody else is 20. That's at least interval, right? Because 40 minus 20, they're 20 years apart. But what is 40 divided by 20? 2, and that means that this guy is twice as old. It means something, so that's ratio. What would 0 mean in an age, for somebody's age? They haven't been born yet. They aren't walking the earth yet. Right? They're still cooking. 0 years. So that, if I went out to catch fish lengths. So like if one fish was 8 inches and the other one is 2 inches, 8 divided by 2 is 4, that's ratio because the answer, that makes sense. 4 times as big. What would 0 inches long be? I didn't catch any fish. What's the length of the longest fish?